Since the 2005 National Electrical Code, or NEC, several updates have been implemented, particularly affecting residential electrical installations. Here's a summary of some key changes. Firstly, arc fault circuit interrupters, or AFCIs, are now required in more locations. This includes all bedrooms, living rooms, family rooms, dining rooms, kitchens, hallways, laundry rooms, and utility rooms. The purpose of AFCIs is to detect arc faults, a dangerous condition that can cause fires, and to interrupt the circuit, preventing a fire from starting. Secondly, ground fault circuit interrupters, or GFCIs, are also more widely required. These are now needed for all receptacles and lighting fixtures in bathrooms, kitchens, garages, outdoor areas, and crawl spaces. The requirements for boat docks and swimming pools have also been expanded, mandating GFCI protection in these areas to prevent electrical shock hazards. Thirdly, concerning smoke and carbon monoxide alarms, significant changes have been introduced. Interconnected smoke alarms are now required in all bedrooms, outside sleeping areas, and on every level of the home. This interconnection ensures that if one alarm detects smoke, all alarms will sound, providing an earlier warning. Carbon monoxide alarms are also required in every bedroom, outside sleeping areas, and on every level of the home that has a fuel-burning appliance to protect against the dangers of carbon monoxide poisoning. Fourthly, regarding lighting, the code now includes specific provisions for light-emitting diode, or LED, lights, reflecting the increasing prevalence and energy efficiency of these lighting technologies. Minimum lighting levels have been raised for various areas, such as kitchens and bathrooms, to ensure adequate illumination for safety and usability. Fifthly, changes have been made to conduit and wiring regulations. Flexible metal conduit, or FMC, is now allowed in residential buildings, providing more flexibility in certain wiring applications. Non-metallic sheaths cable, or NMB, can now be used in wet locations when protected by a waterproof jacket, expanding its usability. GFCI protection is now required for outdoor receptacles and lighting fixtures, enhancing safety in outdoor areas. Sixthly, while not mandatory, whole-house surge protection devices are strongly recommended to protect sensitive electronic equipment from voltage surges, which can damage or destroy appliances and electronics. Seventhly, updates have been made to grounding and bonding requirements. The grounding electrode system requirements have been revised, affecting how the electrical system is grounded to the earth. The equipment grounding conductor, or EG, sizing has also changed, ensuring adequate grounding for safety. Finally, other notable changes include: firstly, the definition of dwelling unit has been expanded to include townhouses and condos, clarifying the scope of the code's application. Secondly, requirements for electrical service have been updated, affecting the capacity and configuration of electrical service entrances. Thirdly, outlet spacing requirements have been modified, ensuring that receptacles are conveniently located throughout the dwelling. Fourthly, the use of nail-on plates for securing cable has been prohibited to prevent damage to the cable. Fifthly, LED exit signs are now allowed, providing energy-efficient options for emergency lighting. And sixthly, lighting control systems have become more prominent, with new requirements for interconnected systems, allowing for more sophisticated and energy-efficient lighting control. Let's delve into arc fault circuit interrupters, or AFCIs, in greater detail. AFCIs are designed to protect against fires caused by arc faults, which are unintentional electrical discharges that can occur in damaged or deteriorated wiring. There are two main types of AFCIs: branch/feeder AFCIs, which protect the entire circuit, and outlet branch circuit AFCIs, which protect the circuit downstream from the device. The 2005 NEC required AFCIs primarily in bedroom circuits. However, subsequent editions of the NEC have expanded the requirements to include nearly all living areas within a home. The reason for this expansion is the recognition that arc faults can occur anywhere in a home's electrical system, not just in bedrooms. The installation of AFCIs involves replacing standard circuit breakers with AFCI breakers in the electrical panel. These breakers constantly monitor the electrical current for the telltale signs of an arc fault. When an arc fault is detected, the AFCI breaker trips, cutting off the power to the circuit and preventing a fire from starting. It's important to know that AFCIs are different from ground fault circuit interrupters, or GFCIs, although they both provide important safety functions. AFCIs protect against arc faults, while GFCIs protect against electrical shock hazards. Moving on to ground fault circuit interrupters, or GFCIs, these devices are designed to protect people from electrical shock by detecting ground faults, which occur when electricity flows through an unintended path to ground, such as through a person's body. GFCIs work by monitoring the current flowing in the hot and neutral conductors of a circuit. If there is a difference of more than a few milliamps between these currents, it indicates that some current is leaking to ground, which could be a shock hazard. When a ground fault is detected, the GFCI trips, cutting off the power to the circuit in a fraction of a second. The 2005 NEC required GFCIs in bathrooms, garages, and outdoor locations. Subsequent editions of the NEC have expanded these requirements to include kitchens, crawl spaces, and other areas where there is a higher risk of electrical shock. The expanded requirements for boat docks and swimming pools are particularly important, as these areas are inherently wet and conductive, increasing the risk of electrical shock. GFCI protection is typically provided by GFCI receptacles, which are installed in place of standard receptacles. GFCI circuit breakers can also be used to protect entire circuits. Regular testing of GFCIs is recommended to ensure that they are functioning properly. This can be done by pressing the test button on the GFCI receptacle or breaker. When the test button is pressed, the GFCI should trip, cutting off the power to the circuit. If the GFCI does not trip, it should be replaced immediately. Regarding smoke and carbon monoxide alarms, the interconnected smoke alarm requirement is a significant improvement in fire safety. Interconnected smoke alarms communicate with each other, so that if one alarm detects smoke, all of the alarms in a home will sound. This provides an earlier warning of a fire, especially for occupants who are sleeping or in other parts of the home. The interconnection can be achieved through hard wiring, wireless technology, or a combination of both. Hardwired interconnected smoke alarms are connected to the home's electrical system and are linked together with wires. Wireless interconnected smoke alarms communicate with each other via radio frequency signals. Combination systems use both hardwiring and wireless technology. Carbon monoxide alarms are essential for protecting against carbon monoxide poisoning, which is a silent and deadly hazard. Carbon monoxide is a colorless, odorless gas that is produced by the incomplete combustion of fuels, such as natural gas, propane, oil, and wood. Common sources of carbon monoxide in the home include furnaces, water heaters, stoves, fireplaces, and generators. Carbon monoxide alarms detect the presence of carbon monoxide in the air and sound an alarm to warn occupants. These alarms should be installed in every bedroom, outside sleeping areas, and on every level of the home that has a fuel-burning appliance. It's important to replace smoke and carbon monoxide alarms every 5 to 10 years, as their sensors can degrade over time. The expiration date is usually printed on the alarm itself. Now, let's consider the changes related to lighting. The inclusion of light-emitting diode, or LED, lights in the code reflects the increasing popularity and energy efficiency of these lighting technologies. LED are semiconductor devices that emit light when an electric current passes through them. They are much more energy efficient than traditional incandescent and fluorescent lights, and they also have a much longer lifespan. The code addresses various aspects of LED lighting, including their use in general illumination, recessed lighting, and decorative lighting. Minimum lighting levels have been raised for various areas, such as kitchens and bathrooms, to ensure adequate illumination for safety and usability. This is particularly important for tasks such as food preparation, grooming, and reading. The code specifies minimum light levels in terms of foot candles or lux, which are units of measurement for illuminance. Concerning conduit and wiring, the allowance of flexible metal conduit, or FMC, in residential buildings provides more flexibility in certain wiring applications. FMC is a flexible, metallic conduit that is used to protect electrical wires. It is commonly used in situations where it is difficult or impossible to run rigid conduit. The code specifies the types of FMC that are permitted for use in residential buildings, as well as the requirements for its installation. The allowance of non-metallic sheet cable, or NMB, in wet locations when protected by a waterproof jacket expands its usability. NMB cable is a type of electrical cable that is commonly used in residential wiring. It consists of two or more insulated conductors encased in a non-metallic jacket. The code specifies the types of waterproof jackets that are permitted for use with NMB cable in wet locations. The requirement for GFCI protection for outdoor receptacles and lighting fixtures enhances safety in outdoor areas. Outdoor receptacles and lighting fixtures are exposed to the elements, which increases the risk of electrical shock. GFCI protection helps to prevent electrical shock by detecting ground faults and cutting off the power to the circuit. Whole house surge protection devices are recommended to protect sensitive electronic equipment from voltage surges. Voltage surges are brief spikes in voltage that can damage or destroy electronic equipment. They can be caused by lightning strikes, power outages, or other electrical disturbances. Whole house surge protection devices are installed at the electrical service entrance and protect all of the electrical equipment in the home from voltage surges. They work by diverting excess voltage to ground, preventing it from reaching sensitive electronic equipment. Updates to grounding and bonding requirements are essential for ensuring the safety and proper functioning of the electrical system. Grounding is the process of connecting the electrical system to the earth, which provides a path for fault current to flow back to the source. Bonding is the process of connecting metallic parts of the electrical system together, which creates a low impedance path for fault current to flow. The grounding electrode system requirements have been revised to ensure that the electrical system is properly grounded. The equipment grounding conductor, or EG, sizing has also changed to ensure adequate grounding for safety. The EGC is a conductor that connects the metallic parts of the electrical system to the grounding electrode system. The updates to the definition of dwelling unit to include townhouses and condos clarifies the scope of the code's application. This ensures that the code applies to all types of residential buildings, regardless of their ownership structure. Updates to requirements for electrical service affect the capacity and configuration of electrical service entrances. The electrical service entrance is the point where the electrical power enters the building. The code specifies the minimum size and capacity of the electrical service entrance, as well as the requirements for its installation. Modifications to outlet spacing requirements ensure that receptacles are conveniently located throughout the dwelling. The code specifies the maximum distance between receptacles, as well as the requirements for their placement in different areas of the home. Prohibition of the use of nail-on plates for securing cable prevents damage to the cable. Nail-on plates are metal plates that are used to secure electrical cables to framing members. However, they can damage the cable if they are not properly installed. The code now prohibits the use of nail-on plates and requires the use of other methods for securing cables. The allowance of LED exit signs provides energy-efficient options for emergency lighting. Exit signs are used to indicate the location of exits in buildings. LED exit signs are much more energy efficient than traditional incandescent exit signs, and they also have a much longer lifespan. Requirements for lighting control systems, with new requirements for interconnected systems, allow for more sophisticated and energy-efficient lighting control. Lighting control systems are used to control the lighting in a building. Interconnected lighting control systems allow for the control of multiple lights from a single location, and they can also be integrated with other building systems such as HVAC and security. Some additional points to consider include that all electrical work should be performed by a qualified electrician who is familiar with the NEC and local electrical codes. Permits are typically required for electrical work, and inspections are conducted to ensure that the work is done properly. It's important to stay up to date on the latest electrical code requirements to ensure the safety and compliance of electrical installations. The National Fire Protection Association, or NFPA, publishes the NEC, and it is updated every 3 years. Local jurisdictions may also have their own electrical codes that are based on the NEC. Regularly review electrical installations and make necessary upgrades to ensure that they meet current code requirements. Older electrical systems may not have the safety features that are required by current codes such as AFCIs and GFCIs. By staying informed and taking proactive steps, you can help to ensure the safety and reliability of your home's electrical system. This information is for general guidance only, and it is not a substitute for professional advice. Always consult with a qualified electrician for specific advice on electrical installations and code requirements. Remember, electrical safety is paramount, and adhering to the latest codes and best practices is essential for protecting people and property from electrical hazards. Keep in mind that this is a summary of key changes, and a thorough review of the current NEC is necessary for complete compliance. Electrical codes are constantly evolving to improve safety and reflect advancements in technology, so continuous learning is crucial for anyone working in the electrical field.